Okay, so one thing to learn today, and then I'll give you a worksheet to do for the rest of class, is how ionic compounds form. So ionic compounds are always in metal and non-metal put together. So let's look at an example of a metal. Use sodium. How many valence electrons is there in sodium? One valence electron, good, so it's in column 1. So we'll draw 1 dot for that valence electron. And then chlorine is a non-metal that we're going to use. Good, 7. Okay. Oh yeah, you can. That's a good point to bring up. So yeah, normally we the way I told you to do it, you would have it like that. Actually, no, I'll keep it like this for now. The reason why I did, and you can move these around if you want to. It's easier in this example to keep it on the side. But yeah, if you're writing just a single Lewis structure or a single dot diagram, it is better to do like I showed you before, where you start from the right and go around clockwise. But in this situation, because we're going to combine them into one compound, you can have them anywhere you want to where it's convenient, because they're not going to stay there. So what I'm going to do is show you how these compounds form by moving electrons around. And that's why I had it on that side, to show that these two are going to be moved around. So we learned about the octet rule, that chlorine needs 8 electrons to become stable. And so chlorine will get an electron wherever it can. Sodium has 1 extra electron, so it wants to lose that to become stable. So if sodium and chlorine are close by, chlorine will take sodium's electron, and sodium wants that to happen because sodium becomes stable when that happens. So they both benefit from this. They both become stable when this happens. So sodium will donate the electron to chlorine. Sodium now becomes what charge if it loses the electron? Positive, good. So we're going to have this in brackets and a positive. So the brackets just indicate that there's a charge on the atom, in this case, a positive 1 charge. And then chlorine now has 8 valence electrons. It gained an electron. No, it'd be something because it gained an electron, right? And so each electron is a -1 charge. So if it got an extra negative charge, it'd be -1, right? So that's how we would show this ionic compound form. So we have sodium +1 and chlorine -1, and positive attracts negative, and that's how we get this bond form. And this is what table salt is made out of, sodium chloride table salt. So that's the simplest form of these compounds. They can get more complex, and we'll talk about more complex one next. But does this make sense to y'all before we move on, how this happens? Okay, so that one was easy. Let's look at one that's a little bit harder to do. Let's do aluminum sulfide. Yes, good. Yeah, these will all be that way. So these will always be a metal with a non-metal. So we're going to look today just at those ones. So what would aluminum's Lewis structure be? How many dots do you see have an aluminum? 3, good. So aluminum is in column 13. So we're going to have 3 dots for aluminum. Sulfur, 6, good. Actually, sorry, that's too many. Okay, so what would happen here? Yeah. Oh yeah, so that's a good, I forgot to bring it up. So what happens when, if you see an IDE at the end, it's a stabilized form of a nonmetal. So when sulfur becomes stable, it becomes sulfide. So what that means is that, so sulfur is 6 electrons. Sulfide would have 8 with a -2 charge. So that's the difference between the two. Yeah, so if that applied for any of them, if you have chlorine, that would be unstable form where you have 7 valence electrons, and then it would become stable when you added an electron to it. Chloride would be chlorine -1, where it would have 8 dots. Exactly. So what we're going to do is we're going to show the stabilized form of this compound, where sulfur would take electrons to get 8, and aluminum would lose electrons. So aluminum would want to lose 3, sulfur would want to gain 2 to become stable. Now, as it is, though, that can't really happen. If you just have 1 aluminum, 1 sulfur, it's not going to happen, because aluminum wants to lose 3, sulfur only wants 2. So there would be no reason for these to react, because aluminum wants to give away 3, not 2, and sulfur only wants 2. But what we could do is add in more aluminums and sulfurs to get the right ratio where they could equally distribute them. So every sulfur would have 8, and aluminums would just lose all their electrons. So the best way to do it would be like this. When aluminum is stable, what charge would it have? Well, so it's going to want to lose 3, right? Like that, because it could gain 5, but it's easier to lose 3. And so it would choose to lose 3 electrons to become stable. So when it loses 3 electrons, it would be a charge of what? +3. So when aluminum is stable, it's going to be a +3 charge. What about sulfur? What charge would that have when it's stable? -2, right? Because it would have gained 2 electrons, right? So sulfur would be -2. So the best way to know how to do this would be to write it like this, write their stabilized charges, and then move them down here like this. Switch them around. And you now have Al2S3. And this would tell you the ratio that you need to have the electrons distributed properly, so that every aluminum would lose 3 electrons, every sulfur would gain 2 electrons. And now we can build out the structure and see what happens. So the first step in these, if it's not obvious how many you need, then do this, switch it around, and this tells you how many you need of each. So if it's at top, it's a charge. If it's at bottom, that's how many atoms you have. So this number, this says you need 3 sulfurs and 2 aluminums. This up here just says you have 1 sulfur with a -2 charge. So everybody clear on that before we go on? So this right here says that we have 2 aluminums, which we'll write out here with 3 dots, and 3 sulfurs with 6. So I'll use a different color for this one. Well, it will mean it. Oh, sorry. Mm-hmm. Oh, down here? Yeah, because they are telling you 2 different things. So the top number just tells you the charge. This down here tells you how many atoms you have. And so this will always be positive, right? You can't have negative numbers of things, right? You can't have negative numbers of cookies, for example. You can only have positive numbers. So same thing here. You can only count numbers of atoms as positive, not negative. For sulfur, you have 6 electrons, and you have 3 of them. Okay, so now we have the right number of atoms. We have 3 sulfurs, 2 Als, like it said. But like we said, aluminum is going to want to lose electrons to become stable. So we'll just start by moving these dots anywhere where you need extra electrons. So we can move 2 of these dots to this sulfur, make it stable. So we'll go and do that. So this one right here, can go down here. This one can go right here. So now this sulfur right here has 8. So we'll just erase these. You with me so far on that? So these 2 electrons right here went to the sulfur. So now the sulfur right here would have 8 electrons. It gained 2, so that's a -2 charge. Now this right here can go up to this sulfur because that still needs 1. That's good. So this one right here can go up here, and then this one over here can go up here. So yeah, so it needs 2 total. So now we'll erase this one, erase that one. So now this sulfur right here has 8. So we'll put brackets around it. That's a -2 charge. This aluminum right here lost 3 electrons. It's now stable. So put that as a +3 charge. And now the only thing that remains would be these 2 electrons right here, which can go down to this sulfur. So these 2 right here, this one can go right here, that one can go right here. So electrons, when you're building up compounds, can go anywhere you need them to go. You can move them anywhere you need. Okay, so now this aluminum right here, +3, sulfur right here, -2. So this would be the complete ionic compound of aluminum sulfide, where you have 2 Als that are +3, and you have 3 sulfurs that are -2. Yeah. No, because they're 2 different atoms, right? I mean, overall, yes, this is a charge of +6, but they're 2 different aluminum atoms, right? So they would just prefer to write one atom as +3. It's just less confusing that way. So this would be the answer that we would have for the Lewis structure of this compound. Are you with me so far on this and how you do that? No outer shell electrons. Now it has core electrons. That's right. So now it has a complete set of electrons. That'll be the most difficult one. You know, the one usually they're going to be easier than this one. That's the most. You know, that's the hardest one to do. I think for right now, I'll give you the worksheet and just have you go through it. So I'll just pass it off first, and then I think you can do this, but let me know if any questions. It's just like we did on the board. Stick with and pass them.
For sulfur, if it's a full, like whatever it's gonna be charging -2, or is it for end?
What do you mean? I'm sorry.
Like the charge for sulfur is -2.
Right. Yeah.
So would it for all of them, like if the aluminum had all 8 of them, would it be charged at -2?
Oh, well, no, it's how many you had to gain. So aluminum would have to have gained 5 to get 8. So aluminum would be a -5 charge if it gained 5 electrons. Okay. Sulfur only had to gain 2 to become stable, so it's a -2 charge.